Hello friends, in this lecture we will see another CPU scheduling algorithm, which is shortest job first algorithm. This shortest job first may be another otherwise called as shortest job next algorithm also, SJN also. Okay, so in this lecture we will see the definition, advantages and disadvantages of SJF and solved problems. The shortest job next algorithm or the shortest job first algorithm, both are same only. The SJF assigns the process that has the smallest CPU burst. CPU burst means total time to execute in the CPU, isn't it? So the minimum execution time process will access the CPU first. Okay, see, in the process are waiting in the ready queue. In this ready queue, first the algorithm analyze the burst time of all the process which is having the minimum, that will get the CPU for execution first. Okay, this algorithm associated with each process CPU burst, and it is a non-preemptive scheduling algorithm and the best approach for minimizing the waiting time of the CPU, and easy to implement in batch systems where required the CPU time should known in advance. This is important. Okay. And next let us see the advantage and disadvantage of shortest job first algorithm. First let us see the advantages. This algorithm gives superior turnaround time for all the smaller processes because these processes will give immediate preferences to access the CPU. The throughput is high. And drawback is the elapsed time, that is the execution completed time must be recorded by the processors. This give some additional overhead to the processors. Then the starvation may occur for longer processes because all the longer processes will execute at last only. And next let us see one problem. Consider the following 4 processes with the length of CPU burst time given in milliseconds. See, 4 processes are there. Their burst time also given. For P1 the burst time is 8, P2 is 4, P3 is 9 and P4 is 5. And they give the arrival time also. With this given data we have to compute the starting time, wait time, finish time and turnaround time. Okay, so this is the problem. From this problem the burst time of all the process are given. Process 1 is 8, 4, 9 and 5. Okay, but with respect to arrival time only the remaining computations will be taken place. The arrival time of P1 is 0. Though the burst time is 8, the arrival time is 0. Hence this particular P1 will start execute first. So starting time 0, waiting time is 0, finishing time is 8. Okay, because the burst time is 8, hence the finishing time is 8 and turnaround time is 8 also. So before this 8, how many processes are available in ready queue? All the other processes came. Okay, arrival time 1, 2, 3 milliseconds, all the processes came here. Now with these 3 we need to select which one is the minimum burst time. This is the minimum burst time. Okay, so this will select for next execution. So the start time of P2 is 8 and wait time is 8 minus 1, which is 7, and finish time 8 plus 4, which is equal to 12, and turnaround time 12 minus 1, which is equal to 11. Okay, so after that with these 2, which one is minimum? This one is minimum, isn't it? So process 4 will start execute next. So what is the finish time of process 2, which is equal to 12? That is the start time of process 4. Okay, and wait time, start minus arrival is wait time. Okay, 12 minus 3, which is equal to 9, and finish time, start time plus burst time is finish time, isn't it? So 12 plus 5, which is equal to 17, and the turnaround time, finish time minus arrival time, that is 14. 17 minus 3, which is equal to 14. and finally the process 3 will start execute this one, okay, because highest burst time. So the start time is the finishing time of P4 is the starting time of P3, and waiting time 17 minus 2, that is the arrival time, which is equal to 15, and finish time 17 plus 9, which is equal to 26, and turn around time 26 minus the arrival time is 2, that is 26 minus 2, which is equal to 24. Okay, so with this value we have to compute the average waiting time of all the process. See, the sum of 0 plus 7 plus 15 plus 9 divided by 4, which is equal to 7.75, and turnaround time is 14, that is average turnaround time is 14.25. Next, let us see another problem. Here also we are having 4 processes and corresponding burst time also given, but they didn't mention any arrival time, hence we have to assume the arrival time is 0 for all the processes. So only these things will be given in the problem, then we have to compute the start time, wait time, finish time and turnaround time for all the processes. Okay, so from these given process burst time, which is the smallest one, P4 is the smallest burst time, so this will start first, and second one is P1, third one is P3 and the last one is P4, P2. Okay, P2 will execute last because the highest burst time. Okay, so when try to draw the Gantt chart here, P1 will start at 0, finish at 3. Okay, finishing time equal to starting time plus burst time. Okay, so start at 0, finish at 3. Here all the arrival time are 0, hence the start time, which is equal to waiting time, and the turnaround time, which is equal to finishing time itself. Everything will be same. Okay, so the P4 will execute first. After that P1 will start its execution at P3. The burst time is 6, so 3 plus 6, which is equal to 9. Okay, after that P3 will start execution. The burst time is 7, so 9 plus 7, which is equal to 16, and the finish time is 16. Okay, and next P2 will start execute here. The P2 will start at 16 and finish at 24. So finish at 24. Now we have to compute the average waiting time. Average waiting time is, see, this time. Okay, the starting time is average waiting time. 3 plus 16 plus 9 plus 0, which is equal to 4 by, divided by 7, divided by 4, which is equal to 7. And average turnaround time, this is the average turnaround time, which is equal to 13. And this is another problem. Here also we are having 4 different processes, but the arrival time is given for all the processes. Okay, the arrival time of P1 is 0. All the other processes are after 0 only the process will come to ready queue, isn't it? So the P1 will select executing first. Okay, because it comes first in the queue. So P1 will start at 0 and end at 7. Okay, so starting 0, finishing 7. See, next P3 is having the shortest burst time. It arrives at 4, that is before 7. It arrives at 4 itself. So this will start execute next. So the burst time is 1. So 7 plus 1, which is equal to 8. Okay, starting time 7, finishing time 8. And waiting time, so start time minus arrival time, that is waiting time. Okay, 7 minus 4 equal to 3. And turnaround time, finishing time minus arrival time, that is 8 minus 4, which is equal to 2. Okay, after that the second process will start executing. The burst time is 4, so 8 plus 4, which is equal to 12. Okay, finishing time is 12, starting time is 8. And waiting time, which is equal to start time minus arrival time, that is equal to 6. And when come to turn around time, finishing time minus arrival time. Okay, 12 minus 2, which is equal to 10. Okay, next P4 will start execute here. P4 will start at 12 and burst time is 4. So 12 plus 4, which is equal to 16. Okay, the finishing time is 16 here. Next, the waiting time. Waiting time is start time minus arrival time. 12 minus 5, which is equal to 7. And turnaround time, finishing time minus arrival time. Okay, 16 minus 5, which is equal to 11. Okay, now we need to compute the average waiting time. Average waiting time is here. So 0 plus 6 plus 3 plus 7 divided by 4, which is equal to 4. And average turnaround time, so that is here. So 7 plus 4 plus 10 plus 11 divided by 4, which is equal to 8. Up to this we have seen the shortest job first scheduling algorithm, which is otherwise called as shortest job next scheduling. So under this we have seen the definition, advantage and disadvantages. After that we have solved 3 different problems. And students, please write in which order the processes will be selected in shortest job first algorithm, and you can write your answer in the comment box. Thank you.